Hello class, this is section 4.4 counting. We're going to learn about the fundamental counting rules. So in a sequence of n events, and in which the first one has k1 possibility and second one has k2 possibility, third k3 possibilities, and so forth. The total number of the possibility of the sequence will be the product of the number of the possibility, which is k1 times k2 times k2 k3 times all the way to k to the n. So this is actually the by multiplying, so we'll do the multiply. So how many different hats? So on your chart has hat patterns in 4 style with the 5 stitch options, 3 sizes, and 8 yarn that are appropriate for the hat. How many different hats it can be made? So these are the four different the pattern. So there are 4 style and 5 different stitch options and 3 different sizes of hat and 8 yarns. So multiply all together, which becomes 480 and different hats. So there's no hat is exactly the same, okay? And then the B. Now, how many hats can be made in size in discarded? So in this time, how many hats can be this? So we're not looking at the size this time. So we ignore the size, and then there'll be a 4 style, and then 5 stitch options, and then the 8 yarns. So it becomes 160 different hats because we're not looking at the size. All right, let's look at the next page. Next example, the sample space for each event will be the same. However, in one case, repetition is allowed, while in the other case, repetition is not allowed. So lottery game. Lottery game called a pick 4 is played by the picking 4 digit 0 through 9. How many sets of the 4 digit are possible if the digit can be repeated? So you can choose a 4 digit. So first, second, third, and the fourth, okay? But there are 10 different digits here. So, but the digit can be repeated. So you have a 10 of the digits you can choose first time. And then the second number, you can choose another 10 as a third, another 10 as a fourth. So multiply 10 times 10 times 10, it becomes 10,000 different ways. How many sets of the 4 digits are possible? The digit cannot be repeated. So there will be a 4 digit you choose. Okay, but once you take out the number, you cannot use it anymore. So first try, you got 10 number. Second try, now you got 9 number. Third try, now you got 8 number. Fourth try, you got the 7 numbers. So multiply all of them together, you get 540 different ways, okay? And then we're going to talk about factorial formulas. So factorial means when you have, we use exclamation symbols. So n factorial. So this is this we call the factorial. So starting from the number that you have and then decreasing by 1 to multiply all the way to 1. But the 0 factorial, I think is 1. Okay, so 5 factorial means 5 times 4 times 3 times 2 times 1. So which is when you multiply that, it's gonna be a what's going on here? Yeah, 120. Permutation. Permutation is arrangement of an object in specific order, that is the order matter. First, consider the instance where all n objects are different. When all objects are used, then the permutation of the n objects n at a time is written p n pn and calculate use the formula npn is n factorial. So we call that n factorial. Okay. All right, let me look at the example. So permutation rule number 1. So when R of the n objects are used in the specific order, the permutation of the n objects R at a time is NPR. It's going to be n factorial over n minus R factorial. Way to visit the patient. Suppose the home nurse has a 6 patient that must be visited in one day. How many different ways can the nurse visit them? So there are 6 patients, right? So in order to get 6 patients, you have to visit them 3, 4, 5, 6, right? So there are at the first visit there are 6 patient, right? But second visit now you have a 5 patient. Third visit you got 4 patient. Fourth visit there's a 5. Oh, sorry, 3. And then the fifth visit now you have a 2 patient left, and the sixth visit now you have a 1 patient left. So multiply all of them together, which becomes 720, which is, you can say that it's a 6 factorial 2, which give us 722. Or you can choose, you have a 6 patient, but you need to visit them all. So which is 6 factorial and n minus 6 minus 6 factorial, which is going to be 6 factorial over 0 factorial, 6 factorial over 1, which is 720. So you get the 720 different ways. If the nurse must be choose 4 from the 6 patients, how many ways you can visit them? So which means now you have a 4 patient to visit. So the first patient, you only choose 4 from the 6. There are 6 patients, 5 patients, 4 patients, and 3 patients, right? So you got 360. So which is second, third, and then fourth. Also you can say there are 6 patients, but you only choose 4. So 4 factorial over 6 minus 4 factorial. You got 4 factorial over 2 factorial, which is give us 360. Oh, sorry. This must be 6 factorial. What am I talking about? So it's going to be 6 factorial and 6 factorial. Okay, so that's the same thing. So you can do it this way or this way. You get the same answer. Okay, now the permutation number 2. So permutation number 2 is about the arrangement of the n object in a specific order using the R1 object identical to R2 object identical. So we have some identical objects to choose. So number 4, arrangement when the some objects are identical. How many permutation of the letter can be made from the word Mississippi? So we're gonna actually rearrange this Mississippi letter. So Mississippi has 1M, 1 M, and then 4 I and 4 S, and then 2 P's. So total number of the Mississippi letter has 11. And then there's a 1 factorial for the M, 4 factorial for the I, 4 factorial for the S, 2 factorial. So if you simplify, I got big number. Divide by 1 times 24 times 24 times 2, which becomes 3,450 ways. Now combination. The combination order actually doesn't matter, okay? But permutation order matter, but combination order doesn't matter. So combinations are used when the order arrangement is not important as the selecting process. Suppose the committee of the 5 members is selected from the organization membership of the 45. The 5 selected committee members represent a combination. So combination is the rule is the number of the combination R. Object to select from the N object is denoted by the NCR. It is given by these formulas, okay? Let's look at this. Okay, so playing bridge. How many different table of the 4 can you make from the 12 potential bridge player? So there are 12 bridge player, but you only choose 4. So which is 12 factorial. You subtract 12 minus 4 is just like permutation, but you also divide by 4 factorial. So which become 12 factorial with the 8 factorial, 4 factorial. But when you use a calculator, there is a factorial, which is I think I want to maybe posting the video that you can watch it. Okay. All right. So if you compute this, it becomes 479,001,600 divided by 40,320 multiplied by 24, which becomes 495. All right, group of the present. If a person can pick 3 presents from the 12 presents under Christmas tree, how many different groups of the presents can be chosen? So there are 12 presents, pick 3. Okay, you pick 3, which means the 12 presents, 12 minus 3 factorial, 3 factorial, 12 factorial over 9 factorial, and 3 factorial. So it's going to be 220. Okay, so, and that's all for the 4.4 as a counting. Thank you for listening.